Section 2.4 is on modeling, and not only are we going to talk about linear models, but we will also be talking about piecewise functions, and anytime you talk about direct, we also need to talk about direct variation with linear. So first of all, let's do a little reviewing from yesterday. Let's see if we can solve this problem graphically. So I'm going to do this first one in red. So across is at 4, up 1, left 1, down 1, right 1. So we get this line. And the next one I'm going to do in blue. 1 minus 2x, so it crosses at 1. And up to left 1. And I get this graph. So then it says where is the red graph smaller than the blue graph? So right here, this red graph goes below the blue one. So from negative infinity to negative 3. And it would be equal there because we have an equal bar here. So all of this is where the red graph goes below the blue graph. Solving numerically, it says where does the function go greater than 0? So first I want to find my 0, which happens right here in my y's, my second list. And where does it go greater? Is it up the table or down the table? And it is up the table. So my x's went to negative infinity as I go up the table to 2. So it would be negative infinity to 2 with a parentheses because there is no equal bar. And now we do it symbolically. So first I'm going to get rid of my fractions. I'm going to multiply everything by 3. So 2x minus 6 is greater than or equal to negative 4x plus 12. I'm going to move my x's to the left. So that gives me 6x minus 6 is greater than or equal to 12. Add 6. 6x is greater than or equal to 18. Divide by 6. X is greater than or equal to 3. Now I'm supposed to do that in interval notation. So I'm here at 3, and I'd be opening to the right. So 3 to positive infinity would be my interval. All right, so when we model, It means we are simply finding an equation that represents the real life data that can be made. So to model something means write the equation to the real life data. And we have two kinds of models. They are either exact or they are approximate. If they are exact, it means every x entered into the model will give me the real life y. If it is approximate, every x entered into the model does not give me the real life y. If we look at correlation, exact models will have 100% correlation, or R equal to 1. If it is approximate, it is something other than 100%. So this first one, we have the model f of x equals 5x minus 2. That same model fit both sets of data. We are to determine if the function f is an exact model or an approximate model. So first we're going to test it to this set of data. So first I need to put in 1. 5 times 1 minus 2 equals 3. And that checks out for my y. So then my next x is 2. 5 times 2 minus 2 is 8. That also checks out. Now I'm going to test my 3. 5 times 3 minus 2 is 13. That does not check out. So this is an approximate model. Because not every x gave me the exact same y. So I'm still using this same model for this data. So still f of 1 still gives me 3. That checks out. F of 2 should give me 8. That checks out. F of 3 should give me 13. That checks out. So I also need to try f of 4. 5 times 4 minus 2 is 18. And that checks out. So this is an exact model, since 100% of the x's give me the exact y's. Now this one says find the linear equation of the exact model. So my linear equation will be in the form y equals mx plus b. So if I find my slope, this change in y's is 2, and this change in y is 2. This change in x is 1 over this change in x is 1. So I get a slope of 2 over 1, which is 2. So my equation is y equals 2x plus b. Well, b is your y-intercept. And your y-intercept is 0, comma, b, or y value. So x is 0. So here would be 0. So if I go back 1, I'm going to have to go back 2. So this would be 7 minus 2 would give me 5. So it is y equals 2x plus 5. Okay. On this one, from -5 to -1 is an increase of 4. From -1 to 1 is an increase of 2. From -6 to 0 is an increase of 6. From 0 to 3 is an increase of 3. So my slope would be 4 over 6 or 2 over 3. So y equals 2/3 x plus my b. Well, this time I have my 0, -1. So it's plus a -1 or simply -1. This says in a linear function, f of x equals mx plus b. The slope is the same as the rate of change, and a y-intercept is your initial amount. So slope is rate of change, y-intercept is your initial amount. So when we look at this real life example, to buy a $1,200 stereo, you pay $200 deposit and make weekly payments according to this equation. A equals 1,000 minus 4t, where A is the amount you owe and t is the number of weeks. So how much do we owe? $1,000. That is our initial amount left to be paid. What is your weekly payment? That would be our slope. It is a negative $40 per week. We are decreasing our bill by $40 a week. What is your domain and your range? Well, my domain in this case are my A's. My domain would be my T's, and my range would be my Y's, which are my A's. Because Y equals mx plus b. So if I put my model here, A equals negative 40t plus 1,000. I see my T's are my domain, and my A's are my range. So if I want my maximum domain, I want my maximum t, I'm going to put a 0 in for x, in for y. So A is 0 equals negative 40t plus 1,000. Subtract 1,000. Negative 1,000 equals negative 40t. Divide by negative 40. And 25 equals t. So that means I have up to 25 weeks to make my payments. So I can have 0 to 25 weeks. To find my maximum range, I'm going to put the 0 in for t and solve for A. So A will equal negative 40 times 0 plus 1,000. That gives me A is 1,000. So the maximum amount of money I have to pay back is $1,000. The least amount of money would be $0. So 0 is less than or equal to A, which is less than or equal to 1,000. So to find your maximum domains, put 0 in for your Y so you get your X's. To find your maximum ranges, put your 0 in for X to see what you get for Y's. So here's the situation. The number of cell phone subscribers in the U.S. increased from 16 million in 1993 to 44 million in 1996. What is the average rate of change? Predict the subscribers in 2007 and interpret the function. So 3 things. So first, I need to determine what is X and what is Y. Would we say cell phone subscribers per year or years per subscriber? We'd say cell phones per year. So this will be my slope. Slope is Y's over X's. So I'm going to say the year since 1990, and I'm going to say cell phones in millions. So my X is my year. This would be 316 and 644. So to find that slope, the difference of my y's over the difference of my x's is 28 thirds, which is 9.3 repeating. So I'm going to use my starting point here. So y minus 16 equals slope times x minus my x coordinate. That gives me y minus 16 equals 28 thirds x minus 28. I'm going to add 16. So I get y equals 28 thirds minus 12. So there's my equation. My average rate of change was right here, 9.3 million. Phones per year. Predict the number of subscribers in 2007. So 2007 minus 1990, because I'm going since 1990, equals 17. So I'm going to put 17 in my x. So y equals 28 thirds times 17 minus 12. And let's see what that gives us. We get 146.6 repeating. So I have 146.6 repeating million subscribers. Give an interpretation of the function. So if I'm coming back to interpret that, I would say the number of cell phone subscribers increases by 9.3 million per year, starting at 16 million in the year 1993. Right? A piecewise function is simply a function that is a combination of equations, and they respond to a certain domain. So it's called piecewise because there is more than one piece. So if we just look at this, if we look at just the symbolic form, we see there are two pieces. If we look at the graphical form, we also see there are two pieces, thus a piecewise. Now, on any piecewise, at the back is always your domain. At the front will determine your equation or your range. So, just to show you how this graph came about, I'm going to do an XY table. I'm going to start with this piece. It says to start with 1, and it will be a closed circle. So when I put 1 into 2x minus 1, I get 1. So 1, 1 was closed. Then it said to pick something smaller than 1, so I'm going to pick 0. 2 times 0 minus 1 is negative 1. So 0, negative 1. And you see I get this piece. Then I'm going to move on to the second piece. It also says to start with 1, but the 1 is not included, so I put an open circle. When I put 1 in there, 3 times 1 is 3 plus 1 is 4. 1, 4, open. Then it said to pick something bigger, so I'm going to choose 2. 3 times 2 is 6 plus 1 is 7. 2, 7, closed. So this is where I started on through here. So my domain, every one of these x values was used, so x is all reals. My range, all the y's up to here are used. Then there's a gap, and the y's up to here. So first, from my y's are less than or equal to 1. Or my y's are greater than 4. So the first part of this says to evaluate. So I am to evaluate f of 0, f of 3, and f of 6. So again, I am going to start with the domain here at the back. Does 0 fit in the top domain or this bottom domain? The top domain. So then I am only going to put 0 into the top function. 3 times 0 plus 2 gives me 2. So at 0, I get 2. Now I have 3. Does 3 fit into the top domain or the bottom domain? Still the top, so I will only put it into the top piece. 3 times 3 plus 2 is 11. And lastly, 6. Does 6 fit into the top domain or the bottom domain? The bottom, so I will only put it into the bottom equation. 6 minus 1 equals 5. When we evaluate, we can only have each value go into one piece. Now it says state the domain and range. So I'm going to look at a graph of this in order for me to do that. When it was 3, I had 11. So 3, 11 was a closed circle. Then when I picked something smaller like 0, I got 0, 2. So here's my first piece. Now, just to find a beginning when I graph, I'm going to put 3 in, but it'll be an open circle, so that means it will not be included. So 3, 2 is open. And then when I pick something bigger like 6, I got 5. So 6, 5. So I see that every one of these x values was used. So again, my domain, x, is all reals. And my range, what y's were used? This y, this y, this y, this y. All y's were used. So y is also all reals. Now it says to graph the function. So there are two pieces, so I'm going to need two XY tables. So I'm going to do this first one in purple. It says to start with 2, but there is no equal bar, so it'll be an open circle at 2. So when I put 2 in there, I get 2/3 times 2 plus 2/3. 4/3 plus 2/3 is 6/3, which is 2. 2, 2, open. Now it says pick something greater than 2. I'm going to pick 3. 2/3 times 3 plus 2/3. 2 plus 2/3. 2 and 2/3. 3, 2 and 2/3. Started here, head towards that other point. One piece is done. I'm going to do the next piece in blue. So I'm going to make a blue XY table. This also says to start with 2, but this time the 2 will be included, so it's a closed circle. Negative of 2 plus 1 equals -1. 2, -1. Closed. Then it says pick something less than 2. I'm going to pick 0. 0 plus 1 is 1. 0, 1. Started here, head towards and through that point. And I have my two pieces graphed. On this one, I see 4 pieces. I also see that's a little bit different at the back. My domain says -4 is less than or equal to x, which is less than 3. So it gives me a beginning and an end. So it says to start at -4, and that will be closed. And it says to end at 3, but that will be open because there is no equal bar. There is also no x over here in the range. So that means -4 just goes to 1. It also means this 3 goes to 1 because there is no place to substitute it in. So it is just that horizontal value. So -4, 1, closed, to 3, 1, open. Horizontal line. Now the next piece. -3, closed, to 2, open. -3 goes to 2. 2 goes to 2. So -3 closed to 2 open. Now I'm going to do my next piece. -2 closed to 1 open. -2 goes to 3. 1 goes to 3. And last, -1 to 0. -1 closed, 0 open. -1 goes to 4, 0 goes to 4. And there I have my 4 pieces. Now, this is called a step relation. It is not a step function because it does not pass the vertical line test. But do you see how it creates steps? So it is called a step relation. If it were to be a step function, it would look like this. Where there is no overlap of terms, and it still creates that step idea. Now, if I give you the equation, can you go the other way and say, excuse me, if I give you the graph, can you go the other way and say the equation? I see two pieces, so I know it's piecewise. So I'm going to write f of x equals, and I'm going to create my two pieces. Back here is always the domain. So I'm going to start with this red closed circle. If I take that down to the x-axis, I see I have x compared to -1. And since it was closed, it will be equal. And they are the values to the left that give me this red piece. So it will be less than or equal to -1. Now I need my equation. So I'm going to count my slope. I see a lattice point here. Up 1, right 1. So that gives me a slope of 1. So this will be 1x. Now, it does not cross the x-axis, excuse me, the y-axis, so I'm going to have to do y minus my y-coordinate. And I'm going to use this point, -1, 1. Y minus my y-coordinate equals slope times x minus my x-coordinate, -1. Negative, negative makes positive. Y minus 1 equals 1x plus 1. I'm going to add 1 to both sides, and I get y equals x plus 2. Y equals 1x plus 2. Now I'm going to do the same thing with the other one. If I look at this green open circle, it is at -1 as well. This time, they're the values to the right that give me this green circled piece. So that will be x is greater than -1, but no equal bar because it's open. Now I need my slope. I'm going to count from here to here. Up 1, left 2. So that is a -1/2 slope times x. I can't tell exactly where that crosses the y-axis, so again, I'm going to use one of my points. I'm going to use this point, 1, -1. Y minus my y-coordinate equals slope times x minus my x-coordinate. This becomes y plus 1 equals -1/2 x. Negative, negative makes positive, 1/2. Subtract 1. I get y equals -1/2 x minus 1/2. And I have my piecewise. Let's try another one. Again, I see two pieces, so f of x equals. I'm going to make a spot for my two pieces. This one, I bring that down to the x-axis, and I see x compared to 0. There are all the values to the right, so it'll be greater than. And I see the closed circle there, so it'll be equal. Now I'm going to count my slope. Up 1, left 1. That gives me -1x, and I see it crosses the y-axis at 2, so plus 2. This open circle also is compared to 0, but they are the values to the left that give me this piece, so that will be less than. And no equal bar because it's open. I'm going to count my slope. Up 1, right 1. Gives me 1x. And I see it crosses the y-axis at -1. Now here's a real life situation of a piecewise. And this is shipping costs. And when we have shipping costs, there's a flat cost rate, so it'll be like the step function. So let's see what we have. Shipping costs of $6 on purchases up to $50. $8 on purchases over $50 up to $100. $10 over 100 and up to 200. Write the piecewise. So f of x equals, and this time I see 3 pieces. So shipping cost of 6, so that's a flat rate of 6, so there should be no x. Y is 6. Up to $50, so that means over 0, but up to 50 would be 50 or less. Then I see $8 over 50, but up to 100. And then I see $10 over 100, but up to 200. So the domain goes from 0 to 200. 0 to 50, 50 to 100, 100 to 200, so from 0 to $200. My range is Y is 6, 8, or 10. And the last thing I'd like to discuss today is called direct variation. When something is direct variation, that means one variable will increase, so will the other. Or vice versa. When one variable decreases, so will the other. They are of the form y equals kx, where k is your slope. It's your constant of variation. So it follows the equation y equals mx plus 0. So there is no y-intercept when we have direct variation. There is only a k, a constant of variation. So the minute we see the word vary directly, we're going to write equals k. And it says x and y vary directly, so we'll just use this equation, y equals k times x. It says y is 15 and x is 3. So I'm going to put 15 in here, k times 3. To solve for my constant, I'll divide by 3, and I get k equals 5. My directions say write the equation, and that's the equation of variation. So I need to put this k in here. So my equation of variation is y equals 5x. Most common mistake made is people will just stop here. They will not write the equation of variation. Step 2 says find y when x is 9. So y will equal 5 times 9, which is 45. So this is all my work, and these are my 2 answers. Write the equation, y equals 5x, and find y when x is 9, y will be 45. Now next it says compute the constant and interpret. Write the equation of variation and estimate the price of 20 ounces of nuts. So I have 4 things. Compute the constant. So that means y equals k times x. Okay? So if I put in my 2.40 equals k times 8. If I divide by 8, I get 30 cents equals k. My constant of variation is 30 cents. Interpret that. Each ounce of nuts costs 30 cents. Write the equation of variation. That would be y equals k 0.30 times x. Now, estimate for 20 ounces. So I'm going to put a 20 in the x. Y equals 0.30 times 20. That equals 6. $6 for those 20 ounces of nuts.